I'm not going to be in on Monday, maybe not Tuesday. So I decided I'm going to make some videos for you to help keep us going with these geometry lessons. You know, I'd rather be there laughing with you guys, but unfortunately I can't, and I do miss you, and I wish I was in. But I'm going to be continuing on what we did Wednesday when we started our proof unit, and that unit, or that lesson, I should say, was showing you the 5 different ways that we can prove triangles were congruent. Those 5 methods we had were side, 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 angle, angle, side, angle, and hypotenuse leg. And what we're going to do is label this triangle based on the information given to us, see which information we have. Do we have 3 sides congruent? Do we have 2 angles and a side, or so on? And then we're going to finish writing these proofs. We call them mini proofs because these proofs are sort of filled in for you and you're just writing in the things that you need. So you're just going to follow along with me. At times I'll tell you can pause the video and try some things on your own and then continue the video. That'll give you a chance to practice on your own in class. All right, let's take a look at this first example. You can see we have 2 triangles here, triangle ADC and triangle BDC. And if you look here at step 5, we're trying to prove them congruent. In order to do that, we've got to label the picture, see what parts we have, and then go from there. So we're not going to know what kind of proof this is, and we're not going to know how to fill these parts in until we label our picture. One thing to mention today, we're going to be doing a lot of what I call the 95% rule. Things like this, where we have midpoint, right? The midpoint's going to give us something on our picture, and then we're going to get over here and we're going to want to write down what the reason is, what the midpoint gave us. And the 95% rule says, hey, 95% of the time, just write definition of, and then the thing that was in the previous step, and usually you're all set to go. So you'll be seeing things like definition of midpoint. All right, let's go to our picture. Let's draw in and label what we have. Based on our first given, we know that CA is congruent to CB, and congruent means that they're the same length. So the person who wrote the proof is giving us the fact that these 2 pieces are congruent. So for this triangle and this triangle here, we have already 1 pair of sides congruent. The next thing we know is that D is the midpoint, and D is the midpoint of AB. All right, it's the midpoint of this side here, and a midpoint will always give you 2 congruent pieces, the left-hand side and the right-hand side of this midpoint. So right now, if you just look at what we have, based on the given information, we have these 2 sides congruent to these 2 sides. I'm just going to write the S's over here so I don't put too much information on the picture and confuse you. We need another piece, right? Is it the angle? We can't just assume anything. The only thing we can do is go by the given information we have and then also take a look at the picture and see if there's something that we would have no doubt would be congruent with the 2 triangles. And if you look right here, you'll notice that this side CD, you're going to see this a lot in our proofs. Both triangles share this side. It was like me mentioning to you on Wednesday that my classroom shares a wall with the teacher on the other side. That means our classrooms have the same size wall. There's no doubt that CD is the same length to the triangle on the left as it is on the right. This is called a reflexive piece. And you're going to see me write the word reflexive in, and that's what that means. Reflexive means CD is really congruent to itself. This will give us the 3rd side of our triangle. And now that we have everything labeled, we could see that these 2 triangles are congruent by something we call side, side, side congruence. So this is perfect. So we've got enough information. We can say the triangles are congruent, and then we can finish our proof. So I'm going to go over here, and I'm going to write in some of the things that we've labeled on our picture. So the given is already here. We already know CA is congruent to CB. That's great. The next thing was D is the midpoint of this line AB, and what that gave us was that AD was congruent to DB. So I'm going to write that in, and you're going to see that here in a second. We're going to say AD is congruent to BD, and the reason was, again, 95% rule, as I mentioned before. This is going to be definition of midpoint. Okay, the midpoint rule gave us that those 2 pieces were congruent. The other thing that we labeled in our picture, which we don't have written here in our proof yet, is that CD was congruent to itself. CD is congruent to CD. This is called reflexive, meaning that something that is in one triangle is shared in another triangle. And triangles can share sides, they can share angles. There's a lot of different things that they can share, but in this case, they are sharing the same side. So now we have the two triangles are congruent. The reason is by side, side, side congruence, and that is what I'm going to write over here. This triangle ADC is congruent to BDC by something called side, side, side congruence. So I'll write side, side, side is congruent to side, side, side. Pretty simple. So today we're just kind of labeling, seeing what we have, and then putting it into the proof. The next proof, I'll start by labeling things, see what you can fill in, and then we can go from there as far as having you watch the rest of the video to see if you did it right. Question 2 says, describe a single rigid motion that would map ADC to triangle BDC. And we can write here that a reflection over line CD, there we go. Reflection over line CD would map A to B, C would map to itself as an angle, D to itself, and all the sides would match. Really, we're matching CA to CB, AD to BD, and CD would land on itself. All right, so there's the first proof. Let's take a look at the next one. In this proof here, you can see that we have two triangles that are sort of connected at this point at angle E. And we are given a couple things. We are given that angle ACE, this angle right here, so let me label that, is congruent to angle BDE, which is down here. We also know that AB, which is a line, this line right here, is bisecting, which we talked about, meaning cut in half. It cuts in half CD. So CD is the thing getting cut in half. If you remember me telling you, when you bisect a line, you get two pieces of a line. When you bisect an angle, you get two pieces of angle. If you bisect a puppy, you get two pieces of the puppy. Okay. All right, so AB is actually bisecting CD, which means this piece right here, CE is congruent to DE. And now we need a third piece. We're out of given statements. So if you look at this picture, think about for a second what the next part that we can label is. And we've already used our given, so it's got to be something in the picture that no one would argue with. You'd look at it and go, oh, those two things have to be equal. All right, so if you look at it, what we could say is that this angle right here, which I'll call 1 and 2, are equal to each other or congruent because there's something called vertical angles. And we learned about this earlier in the year, right? We learned that if you have two vertical angles, they're automatically equal to each other. So if you said vertical angles, that's great. And now we have three parts that are congruent. Let's see what parts we have. We have an angle here. We have a side. And we have an angle. So this ends up being an angle, side angle proof. That is the order that these things are congruent in. So now we're going to write this up. We have to put in the information in here based upon how we labeled our picture. We already have ACE is congruent to BDE. At this point, I would ask that you pause the video and let the students try to write up this proof and fill in the blanks. All right, so after you've given this a shot, let's see how you did. We had our angles congruent. We have AB bisecting CD, and what AB bisecting CD gave us was that CE was congruent to ED. So you should have CE is congruent to DE, or you could have those letters reversed. You can have EC is congruent to ED. And this was definition of a bisector. Okay, so bisecting, bisect. Definition of bisector. The next thing we got was that angle 1 was congruent to angle 2, and this came from our definition of vertical angles, or you can write vertical angle theorem, or however you want to write it. Sorry, I'm just looking for my little angle thing here. It's in here somewhere. Let me find it. I'm trying to get all fancy with you guys. And I know it's here. And the bills are on right now, by the way. Oh, there it is. It's all the way at the bottom. All right, so we got angle 1 is congruent to, and I'll just do this to speed things up here, or not. Work with me here, guys. All right. Angle 2. And the reason was vertical angle theorem, or definition of vertical angles. And finally, we have the two triangles are congruent, and the reason that they're congruent, we said, was angle side angle is congruent to angle side angle. Angle side angle congruent to angle side angle. All right, describe a single rigid motion. Well, we've got to be careful here because we know C is going to map to D. We know A should map over to B. And then these two angles are going to map to each other. So if we rotated C 180 degrees to D, rotated A 180 degrees to B, we would have the two triangles congruent. So we would say it would be a rotation of 180 degrees around point E. All right, so we've got one more proof to do. Let's take a look at what we've got here. Looks like we have two triangles very similar to the one that we just had in the last problem, but let's see if we got something different. They're giving us that IL and HK bisect each other. IL and HK are bisecting each other. Now this is important because that means they're cutting each other in half. So that means you get two sets of congruent segments, which is great here. So let's draw this in. We're going to get IL and HK bisect each other. So we have IJ congruent to JL, HJ congruent to KJ. That right there, notice it's a short proof, already is giving us two out of the three pieces we need. And if you go back to the last proof, I think you can see what that other missing piece is. A lot of times we're going to need to find something that is not given to us. And here, once again, we've got our vertical angles. We have an angle here. Sorry, not an angle. Let me erase that. There we go. We've got a side here. We've got an angle in the middle and a side here. So this is a side angle side proof. So we're going to write this up. Go back in if you want to pause the video and let the students try to write this up. See how they do. But yeah, this is sorry, I'm just watching Kelvin Benjamin. Yes! And a face mask. All right, let's write this proof up. Give him some time to try it out and then come back. All right, so we got a side angle side proof here. Let's type this in. The bisecting of each other is great because it's going to give us two sets of sides that we need. And one of them is going to be that IJ is congruent to LJ. And the other one is that HJ is congruent to KJ. And definition of a bisector, or definition of bisector, or segment bisector, or not bidector, but bisector. There we go. The third thing we had here was our vertical angles. So I'm just going to go back and kind of steal this from here, right? Make it fast. Angle 1 was congruent to angle 2. And this was a vertical angle theorem, or definition of vertical angles. Finally, how are the triangles congruent? Well, we've got two triangles congruent based on these three things that we've labeled here, and this was side angle side congruent to side angle side. Side angle side congruent to side angle side. Why are these triangles congruent? Well, again, this is our rigid, yes, touchdown, Bills. Sorry. This is rigid motions, and this would be a rotation of 180 around point J. So I'm going to put that in there, switch this to point J, and we are good. So this is our first video for the front of the page. I'm going to make a separate one for the back of the page, and hopefully you guys are okay with this. We'll try this out for a few days, and when I get back, hopefully I'll be back in business. All right, enjoy. Why don't you give the ones on the back a little shot and see how you do with them, and I'll have a video for you to practice. All right, take care, guys. Talk to you shortly.